don't have, no, I need the jeans as well. Yeah.
Good. I just noticed it. You guys are right.
Once you see it, you can't unsee it. Hisham, Hisham, I'm pulling this off better than you don't. FYI.
Drop the mic. Hisham, look, it's Daddy.
You show him who's boss now. Yeah, don't stand for that. Yeah. Right. Okay. So the next topic now, the practical problems. So this question, just so you know, this question here is usually a section B question in the exam. Okay, section B. So this is good and bad news. So the good news is you don't have to do it because it's a section B question. But I really think you should practice these because they are good ones to do in the exam, because the advantage for these questions is that they're so similar each time then. So there's a couple of examples here on the worksheet, and what I'll do is I'll go through a couple of them and then leave the rest here for you to try. So if you want, actually I can put it up on the screen here, if we can have a look at the first question. So we'll just look at number 1. So before I start, just to say that there isn't anything new in this lesson, it's just using what we've done for practical problems then, okay? So if we just have a look at the first one here, let me just put it on both.
I think that's the we're done, right? We only have one more section left.
Now what's left to do after the calculus, we have to get to here, at least. Oh yeah. Is that showing up? Hey, look. We need to get to here as a minimum. Hey, come on. We need to get to here as a minimum. So right now we're here at the practical problems. Yeah. So what I usually like to do is I don't like splitting this chapter. It doesn't make sense. But for the exam purposes, the material for the syllabus is actually only up until here for the exam. But I would like to do all of this before the break because I don't like the idea. Yeah, I don't like the idea of splitting the chapter up. Do you know what I mean? Well, look, we'll see how we get on when we get to here, okay? If there's plenty of time, we can do these as well, or we can just give more time to some revision.
How about we don't take this chapter and give some time for revision, more time?
Yeah. This chapter?
No, half. It means half. Don't take half the other chapter.
Yeah, well, we'll see when we get here how much time we have, and we can decide how much we want for revision then. Okay. So we're a little over halfway through the calculus, so we're looking at the practical problem. So let's have a look at question 1 here. So a cannonball is fired up into the air vertically. The height h is given by this equation. So if you can just write this equation down. T is the time and h is the height. So just make note of this. Okay. Kirsty, did you write this down?
What?
Do you want to write the question now?
What question? I can't see anything.
There's a question there. The equation here. Write this down.
I can't see it.
Oh, he doesn't write that. No way.
I don't have my glasses.
For me.
Wow. Okay. Did you write this down? Yep. So the first question is, when is the cannonball at its highest? So if you remember from last class, if we think about the graph, for example, here is the height and here is the time. So what will happen is, as time goes by, the height will increase it will reach a maximum and then it will decrease. So we're looking for this maximum here. So what's special about this maximum?
Is 0.
The derivative is 0. Now it's not dy dx though. What will it be? dh dt. And that will be what exactly here? 100 minus 10t. And we want this to equal 0. So t equals 10. No, 10. Now, we need to make sure it's a maximum and not a minimum. So what should this equal? Positive or negative? Negative. So what is the second derivative here? Minus 10, which is negative, so therefore it's a maximum. That's part A, and then part B is simply, what is the maximum height? So how can I do this, do you think? Just sub the t in, yeah. So I get 100 times 10 minus 5 times 10 squared. So so it's 500 meters. Okay. So that's just a basic question to get started, but we'll look at more complicated ones now. So if you have your phone or book, if you want to start reading number 2 while people are writing this down, so we'll do number 2 next.
I think this is going to be easier than the other practical problems, right?
I think so.
Kind of straightforward.
If you want, you can open on your phone. We'll have a look at number 2 here. Can I switch the screen to it? Yeah? Okay. A manufacturer wishes to produce an aluminium can. 1 square centimetre of aluminium costs 0.03 pence, where 1 pence means 1 penny, which is 0.01 pounds. So 100 pennies in 1 pound, and 0.3 pence is less than 1 penny. Okay, so for 1 square centimetre, it's 0.03 of a penny. The manufacturer wants the can to hold 330 centimetres cubed, so this is a regular size can of cola. So the first part A is express the volume of the can in terms of height and radius. Sub in the value for phi to produce the constraint equation. So let me explain what's happening here. I'll just draw what the situation is. So you're trying to make a can of cola. And there's a few requirements. Well, actually, there's only really one requirement. You just need the can to have a volume of 330 centimeters cubed. Now, if you think about it, there's actually many ways you can make your can. So, for example, you could make this really big, small, and make this really big, or vice versa. You could make it the or really big and the h really small, or the or really small and the h really big. But of course, the best shape must be somewhere in between the two. What exactly is that shape? So this is what we're going to try and find. So firstly, let's calculate let's use a formula for volume. Does anyone know the formula here for volume?
Yeah.
No?
R
Pi
squared times h.
r squared h.
Times h.
And this will be 330 equals pi r squared h. Now, just for a little bit of vocabulary, if I just switch back to the question for a second, this is called, if you can see it here, the constraint equation. Constraint equation. So what that means is, typically for these questions in the exam, there's some condition that you must meet. So for this question, the condition you must meet is that the volume is 330. And we can put this in an equation on or and h. So in other words, I'm saying that whatever or and h I use, I have to make sure this is true. So this is like a constraint or a requirement on the or and the h. So we call it a constraint equation. So this is part A done then. And we can rewrite this for part B, is calculate Oh yeah, so part B needs to use this one. So can I go on to the B part now? Do you have this?
Yeah.
Yeah. So part B is how much does the can cost to make? So what do I need to look at if I'm making the can? I don't care about the volume. What do I care about when I want to know how much it costs to make the can? Yeah, so what is that? Square centimeters? The area. So if I want to know how much the can will cost, I need to know what the area is because I'm paying per square centimeter. So, does anyone know the formula for the area here? Something.
Is it 2
Yeah, so it's 2 pi or h plus 2 pi or squared. Now, I'll give you a warning here. None of these formulas are in the formula book. You're expected to know these from middle school.
Mid school.
Middle
of course,
school.
we have no life.
Middle school.
Not high
We
school.
have no life. We just, we just have no.
I know this. Are you saying I have no life?
I didn't say anything.
You did.
He did.
Guys, make any
Yeah.
words?
Right, so you're expected to know these. So for B part, it says express the cost in terms of H and R. So I've done the B part now already, so B part's finished. Can I go on to C part now? That's it for the B part. I'm breaking down the steps. What I could have done for this question in the workbook is I could have just said, what is the best size for the can? But what I've done is I've broken it down into like 5 steps. And the reason I did this is because in the exam, this question will be broken down into steps as well, and these are the steps. So step 1 is usually constraint. Step 2 is usually you find the thing that's of interest. In this case, it's the area. We care about the area because that's how much we're paying. Now, part C is what is the cost. So remember I said it's 0.03 pence per centimeter squared. Yeah.
If the 1 square centimeter will cost 0.03, doesn't that mean that the total cost will be that the area times 0.03?
Yeah, that's what I'm doing next for part C is what's the total cost. So the total cost will be 0.03 times A. Is this what you mean here?
Yeah, but
Yeah.
when they said express point B, they said yes, no, mine.
Oh, sorry, I didn't finish. I get what you're saying. Sorry, I'm moving a little bit too fast. I'm actually finishing the B part here. Yeah. So for the B part here, the cost equals 0.03A, which will be 0.03 times 2 pi or h plus 2 pi or squared. Okay, so that's the end of the B part.
Sorry, I have
Yep.
one question, but how do you get this equation again?
Which one? This one?
Yeah, H.
No, this one here should be memorized. This is the formula for the area of a cylinder.
Cylinder.
Yes.
You have known it from
Yes.
middle school.
Yes, indeed. C. What is the cost in terms of ore? So when we look at the last one, the cost is in terms of ore and H. And this time I want a formula for only ore. So any ideas on what I can do to...
Substitute for H.
Yeah, substitute how though for H?
Go
Go back to the original. I can say here that H equals 330 over pi r squared. So I can use that instead. 2 pi r, and then H is, what did I say, 330 over pi r squared H, wasn't it? Plus 2 pi r squared. I'll clean this up a little bit. 0.03. There's no... Oh, sorry. It's just pi r squared, was it? Yeah, I'm getting rid of the H, of course. Right. So now we're left with 660 over r plus 2 pi r squared, like that. Or if you want, that's 0.03 660 r minus 1 plus 2 pi r squared. So this is the cost. You know, if you choose a radius, you know how much that will cost you to make. Yeah. Now, part D is what is the value of ore that would minimize the cost. So I want to make the cost minimum. So what could I do to find that? The derivative here. Now it's not dy dx, what will it be here? The cost the ore. So this will be 0.03. Yeah, now what's going to happen is I'm going to find the ore here and sub it back in to the h at the top here to get the h. But at the moment I have an equation with ore. I'll use that to find ore and then get the h. So here I have minus 660 ore minus 2 plus 4 pi ore, and this should equal 0. Huh? Minus 2? Bring the power down and minus 1 to the power. Yeah? Is that okay? So I have minus 660 or minus 2 plus 4 pi or equals 0. Minus 660 over or squared equals minus 4 pi or. 660 over 4 pi equals or cubed. So if you just hit this in on the calculator, or equals cube root of 660 over 4 pi. What's that? And then once you have that, you can get the h, because we said earlier h is, what was it, 330 over pi or squared. Yes, Nathan? What? Yeah. Okay, what's the number here? And that's in centimeters, and here that's in centimeters. 3.74. Yeah. And I think this one is like 7.5, maybe something like this one. Oh no, more than that, isn't it? 7.5, yeah. 7.5 centimeters. So what you've just done is you've said, if I make the can 3.74 this way and 7.5 this way, that will be the cheapest I can make the can. That will have the minimum cost. It will hold the 330 that I need, but it will use the least area, and so the least cost. So this will make it a minimum. So the very last thing is to work out what that cost is. Yeah? Yeah, so what's happened here is, if I use this radius and this height, the can will hold 330. I know that's guaranteed. But the cost will be a minimum. Well, actually I should double check it's a minimum. The second derivative here should be positive or negative?
Minimum, right?
Minimum, so it should be positive. So a quick check here, what's the second derivative here? If I bring the power down again, what do I get? No, 660 times 2. 1320 or minus 3 plus 4 pi. Now I don't even need to calculate this, because I can clearly see when I put a positive number in here and a positive number in here and add them together, the result will be positive, which makes it a minimum. So I know for certain that this will be the minimum cost. The cheapest way I can make the can is with this radius and this height. The last part is to work out what that cost is. So you just substitute these back into your formula. 0.03 2 pi or h plus 2 pi or squared. So can someone just type that in, please? Just be careful with the brackets. What is this? 7.9 pence. So actually in pounds that would be about 8 pence. It'd be about 0.08 if you want to write it like that. You don't have to. You don't have to.
You mean you rounded it up to
I just rounded this up to 8 pence. I said the answer is roughly this. Yeah?
right.
Yes, yes, yes? Continue? Yeah. So the next example I want to do was actually an exam question, except in my story I'm talking about a coffee shop, but in the exam it was a DVD store or whatever. But it's a good example of what an exam question will look like for this, because it's a section B question. It's broken down into 5 parts. So what I like is that this is an entire section B question, a long question. Yeah, I'm skipping number 3 because number 4 there's a bit more. Number 3 is not too bad. Number 4 there's more in it that might be confusing, and it was an exam question. So we'll have a look at number 4 now. Okay, so if I just put it up on the screen here for a sec. Right, so this is a real life example again. When the price of coffee at a coffee shop is €2, then the demand is 100. So what that means is, per day, if they charge €2, then they'll get 100 customers buying coffee. So that means when the P is 2, the Q is 100. So P is for price and Q is for quantity. When the price is €1, no surprise, you get more customers. When the price is €1, there's 150 customers. So that is, when P is 1, then the Q is 150. Also making it realistic, the coffee shop has a fixed cost per day of €70. What do you think I mean by that? Like, what's a fixed cost for a shop? It's a minimum. So what would that be for a shop? What could that be? A cost that they have to pay every day? Rent is one. What else did you say? Yeah, rent. It doesn't matter if the shop is open or closed. They have to pay a rent every day. What else? Maybe a salary if it has workers, yeah. So there's a minimum fixed cost of 70 regardless of what happens. But of course, if the shop is busy and they sell lots of coffee, then the cost will go up, because then they have to buy more cups, buy more milk, and so on. So we have something called a variable cost. That's how much it is to make each cup of coffee. So before you even sell your first cup of coffee, you have to pay €70. And then every time you sell a cup of coffee, you have to pay 33 cents. The shop has to pay. For example, it has to pay someone to make the cup, it has to buy the cup, it has to heat the water. So this is what's called the variable cost. It's the cost per cup of coffee. Yeah. So what we're going to do is we're going to go through these to work out what is the best price for the cup. Because if you think about it, if you have the price too high, will you get more or less customers? You'll get less, which means less sales. But if the price is too low, true, you get more customers, but then what will happen with your money if the price is too low? Well, you're getting less money because the price is lower. People are paying less. So there must be some point in the middle that gives you most money. Not too high, not too low. You get the idea? So I know this seems quite difficult, but we're going to break this down into steps. So the first step is to find the equation for quantity and price. So I'll show you now on the graph in a second. So if we think about it like this, what is the thing that the shop can change? They can change the price of the coffee. So I'll put price on the x-axis. And then when they change the price, what changes after that? The quantity. So when the price was €1, how much was sold? 150. But then when the price is €2, what's sold?
300.
No, I think it was 100, wasn't it? So, as you can see, as the price increases, the quantity decreases. So what we'll do is, we'll think of this as a linear equation, something roughly like that. Okay, yeah. So we have y equals mx plus c, although it's not y and x here, but rather q equals mp plus c. We still have the same formula for m. It'll be 150 minus 100. 150 minus 100 over 1 minus 2. Just be careful there. So this is minus 50. So I have q equals minus 50p plus c. How do I find the c normally? I use a point.
Yeah, use a point.
So I'll use the point here, 150. So now I have 150 equals minus 50 plus c, so c equals 200. So we've done part A. Part A is that the quantity sold will be minus 50p plus 200. Now that we have this formula, we haven't done much, but what's nice is we already have some interpretation power. For example, I can look at this formula and tell you what is the most anyone will pay for a coffee. So in this example, for this shop, what is the most anyone will pay for a coffee and why? No? No? No?
200.
4 euros is the maximum. No, 4 euros. Why 4? Because if the P is 4, what's the Q? 0. So nobody will buy any coffee when the price hits 4. So the price has to be less than 4 before you can start making sales. Also, if the coffee is free, how many will be sold?
Increasing.
No? I know in real life possibly, but for this equation. Yeah, if the P is 0, in this example the Q is 200. Now, of course, that's not realistic, but it's not too bad. The reason it's not realistic is because we drew our graph like this. Whereas in real life, there will always be some idiot that pays more than 4 euros for coffee. And in real life, there'll be more than a 200 demand when it's free. So the graph is probably more like this shape.
There's going to be a sale too.
Yes.
You can do this discussion, that's fine.
Continuing. Right. So are we okay with getting this formula? Yeah, right, zoom out a bit. Do you have this part done? Yeah. Now, part B. The total cost is the fixed cost plus the variable cost. And I want you to find a formula for this. So, for example, what is the fixed cost for the shop? 70. And what is the total variable cost? And remember, they sell Q number of coffees. Well, how much do they have to pay per coffee, did I say? 33 cents, yeah. So if they sell Q coffees, then the variable cost will be 0.33 Q. So for example, if they sell 0 coffees, what's their cost? 70. And if they sell 1 coffee, what's their cost? 70.33. And if they sell 3 coffees, it's about 71 euros. Now I said, what is the total cost for P, not for Q? So what can I do to get a P here instead of a Q?
When you mean total cost for P instead of Q?
I mean, I want it in terms of P, not in terms of Q. So what can I do here to get this in terms of P? Substitute here. Again, can you see the format for these questions? First we try to make an equation, and then secondly we have an equation of interest, and then we substitute in. So now we have total cost is 70 plus 0.33 times minus 50p plus 200. So total cost would be 70, what's minus 50 times this? Can someone type that in? Is it 16.6 or something?
Minus 16.5.
16.5. P plus 66. Is that right at the end?
Yeah.
So the total cost is, what's that? 136 minus 16.5 times the price. Yeah. So, what would be the value of P to make the total cost really, really big? Well, what happens if the price is 0? What's the total cost? 135. Yeah. If the P is 0, this will cost the shop 136 euros. So they have to pay their fixed cost and the cost of making all those free copies. What happens when I increase the price? This decreases. So at the moment it seems like we should make this really big, but what happens when it's past 4 euros? No one buys it. So it's not enough to look at the cost, we also need to look at the sales. So the next thing is, what is the total revenue? Revenue is another word for sales. So how many copies were sold? What's the letter? Q. And what's the price we're selling the copies for? What's the letter? P. So the total sales would just be Q times P. How many cups of coffee times how much you sold them for? Makes sense, right? So what's the formula for Q? We said it's minus 50p plus 200 times P. So yeah, minus 50p squared plus 200p. Okay. So when you think about it, at the end of the day, it's not really the cost that the shop cares about, and it's not really the sales that they care about, but what? The profit, yeah. We really care about the profit, how much money we have after the sales, after the cost. So the profit will be total sales minus total cost, how much money you have left. So in this example, the profit is minus 50p squared plus 200p minus 136 minus 16.5p. So the profit is minus 50p squared plus 200p minus 136 plus 16.5p. So that would be minus 50p squared plus 216.5p minus 136. And this is the profit. So if the profit is 0, if the price is 0, what's the profit? Yeah, so it's a loss. They're losing money. Why are they losing money? Their price is 0. So they have to make all the coffee and they get no money for it. Yeah? But remember, what did we say happens when the price is 4 euros? No one buys. So will the company make a profit or a loss? A loss. So can you just put in 4 euros and see what you get there, please? The 4. You get 0, don't you? Yeah. Wait, no, 0? No.
Minus 136.
Minus 136? Minus 5? Minus 70.
Yeah.
Really? For when the price is 4?
Yeah.
Minus 70.
Okay, it's minus anyway, which it should be because people aren't buying.
How could you lose your... Does that make sense? Could you lose your fixed
cost, yeah, you still have to open the shop. What shape is this graph? Concave or convex? Concave. It's a quadratic, So you can see what's going to happen. This was the price when it's free, and this is the price at, what do we say, 4. So somewhere between 0 and 4, there will be a price that will give you the most profit. How can I find that here? Derivative. So what's the derivative here? Minus 100p plus 216.5 should equal 0. So the p will equal 2.165. So the price, yeah, 2.17. Yeah. So this is the price that the coffee shop should sell the coffee at, €2.17.
Now let's start with that.
Yeah. Don't worry, there's plenty of people in Starbucks HQ working this stuff out. Now, can you just take out your calculators and put this p value back into this formula and tell me what the profit is, so?
98.4.
Euros, and this is per day. 98 was it? Sorry, 98.4. Okay.
98.4.
Yeah. Now, what would happen if the shop was charging $2.17, and then let's say the next day it decides to make more money, so it increases the price to, let's say, €2.27. Will the profit go up or go down? It'll go down, because we just said this is the maximum. And likewise, if it was charging $2.17 and it drops the price to say €2, will the profit go up or go down? Go down. So it can't do any better than this. This is the best it can do. Yeah. Now, what's more interesting is, imagine the situation. The shop was selling coffee for, let's say, €2.50, and you look at the numbers, and then you say, well, actually, the best price is $2.17. So if the shop was charging $2.50, and then you recommend it drops to $2.17, what will the shop see happen to its profits? Will it increase or decrease? It will increase, because $2.17 was the maximum. So by charging $2.50, it was actually reducing its profits. Now this is it will increase the profit. Yeah. Now this is interesting, because what you're telling the shop is, if you want to make more money, you need to reduce your price. Exactly. The extra people that come from the reduced price make up for the reduced price. They more than compensate for it. Yeah. Now, just one more. I won't do it, but just one more famous example of this, where you have the result that you should reduce the price to make more money. It doesn't seem right. You think more price, more money. But you can see here, if the shop was charging $2.50, it needs to reduce the price to make more money. So another important example, and I want to give you some context, because they like giving these questions in the exam, practical examples. So this is for a country, and each country decides how much to tax its citizens, from 0%. Yeah, exactly, 0%, and 100%. I don't know, North Korea or something like this. Yeah. So we're going from something like UAE to North Korea or something.
Oh.
Yeah, something like this. North Korea. You know this place? Okay, that's good. Right. Listen. Hey. Listen. That's great. Listen. So, this is the tax the government can set and this is how much money that the government gets. So what happens if it sets 0% tax? How much money will it get? Well, of course, it will get 0. And if it increases the tax a little bit, like to 1%, what will happen? It will get some money. Now, Nathan, you're making me repeat myself, which is going to hold us all up. So when it's 0%, it gets no money, €0. And when it's a small percent, like 1%, it will get some money. Now, what will happen at 100%? How much money will it get? A lot? A little? A lot? So I should put it up here?
A lot.
Yeah. At 100%, you get no tax. You get no money. Because if the government put 100% tax on my salary, I will not be teaching you. Yeah. So if the government puts 100% tax, why would anyone stay? Why would anyone work? Why would anyone do anything?
Because to your country.
Yeah, exactly.
You have love to your country in your heart. You can live.
I'm not here because I love to teach you. I'm here because I'm paid. Still true.
I'm not here because I love math, but I'm here because I'm forced to be here.
Exactly. So you are here to get a result at the end, go to university, and I'm here because I'm paid. This is our understanding, and that's fine. That is perfectly normal, and that's fine. No. So, at 100% we have 0, and at 0% we have 0. As we increase it, we get some more people, and then here, if we charge less than 100, like if it was 70%, we still will get some money, but not a lot of money because people will still leave. So the graph, what shape will it be, do you think? It'll be a concave shape, some shape like this. But, maybe it's leaning more over to the left, for example, or it could be the other way. So it might be something like this. So it is possible for a government, if it's charging a tax that's too high, to decrease the tax rate. And what would happen to the government's money? It would increase. And this has happened before, where the government cuts the tax rate because it's too high, and instead of getting less money, it'll get more money. So the real trick is calculating what is the percentage, the optimum amount that will give you the most money. And if you try to do more or less than this, you'll just lose either way. Okay? So all these practical problems, we're usually looking for the best situation then. Now, these are all exam type questions. Every single one I've done and everything on the worksheet is an exam type question. So it's really, wait. Tomorrow's tutorial, I'm going to do some more of these. But it's going to be a waste of time unless you try some of them tonight. You should be able to do all of these. I've done 1, 2, and 3. Try the other ones. Okay? Alright, we'll leave it there.